My name is Hussen Premier. I'm a computer engineering major, and for this project, I worked on the wireless communication, various testing of embedded systems and such.
Hi, my name is Jasper Steensma. In this project, I did some work on the PCB, I did some work soldering and building, and then I also did some work on the embedded systems, including building the website behind me.
Hello, I'm Hoang, and I worked on the gun design and the vest design, and some of the CAD models.
Hello, my name is Veciana. I'm an electrical engineer, and I worked on the PCB design and the power supply.
Welcome to Neon Nights. This project, we're trying to build a fully functional laser tag system. So in this system, we want to differ from other laser tags because we want to include more wireless technology. A lot of other laser tags have thick cables that go between and just things that are annoying. So we wanted to make this very seamless and easy to enjoy. So that's why you can see our gun and our vests are all wireless and they communicate to each other. The reason we chose this project is because we wanted the project to be fun. We wanted this to be fun to make, fun to play with, and just enjoyable as a whole.
Okay, so for the gun and vest design, these are the actual internals of the gun and the vest. Here, we actually 3D printed the gun in 3 different ports. You have the main housing, the barrel housing, and now the lens housing. Here you can actually see the different components. I used a spring for the trigger. The reload system is actually using a read switch to actually sense if the reload magazine is inside. For the vest, we just compacted the sensor and the color LED into one piece. So one area will actually light up depending on which area you're getting shot. Here you can see the 3 areas in the front and also the one in the back right here. All the wiring goes to the central piece, also containing the PCB, the batteries, and the power switch.
Okay, so for the vest and the phaser PCBs, we are powering them using 4 AA batteries. They provide about 6.2 volts. We use the AMS 1117 voltage regulator to turn that 6.2 volts into 3.3 volts so that MCU can use it. So for our vest and phaser PCBs, we are powering them using 4 AA batteries. They provide about a 6.2 voltage power supply, and using the AMS 1117 voltage regulator, we convert that 6.2 volts into 3.3 volts. Because we have such a low power supply, we actually ended up going with a low dropout voltage regulator, which allows us to use a voltage that is low and close to our 3.3 output. This is the PCB for our vest. This is how we wire the different zones. Each zone has is connected to its own GPIO pins, so they are not in series. They don't work together.
Here is our LCD screen. We have our bullets and our health. So if I shoot, you can see on the LCD screen the amount of bullets and the number goes down. Eventually, you run out of bullets, and now nothing happens. So now we have to reload the magazine, put it back in, and it'll repopulate our bullets here. So now we can show the health. So Kevin will shoot me and we'll show how the health changes on the gun. I died. He shot me 4 times because I made him have 25 damage and I have 100 health. And then I die, wait 5 seconds, and then I respawn. So we can show this again. So Kevin, shoot. You can show here. Oh, he had to reload. 75, 50, 25, and now I'm dead. It waits, and then it repopulates here. Perfect. So that's how the game mode works. So now we can see he's killed me twice. So here's Rocky, which is Kevin. He's killed me twice, and I've died twice. So he has a 2 KD, and I have 0. So that's how the scoreboard updates, and that's how the LCD updates, and the general gameplay. So here we're going to show how our haptic motors work. Inside the gun and inside the vest, we have these vibration motors. So these things will shake when you're shooting. So for example, if I shoot, maybe you can hear it, but there's a vibration inside the gun on your hand, here and here. So both of your hands will shake every time you shoot. Also, when you get shot, your vest will shake. So if Kevin shoots me, Now I'm dead. But you can hear it. So there's a vibration motor right here. So every time I get shot, I feel it.
One of the main aspects of a project is the wireless communication. There's no wires whatsoever between any player or the computer. So the way this works is, we have the main board. It's receiving data from every single vest. It's sending data from every single zone. Every single receiver is giving the data to the main hub. And when the main hub receives that, it processes all the gameplay and everything. And it sends back the data to the vest to either light up red or whatever the team name is. And it's sending it to 4 different ESP32. Here we have the main hub. The main hub is simultaneously getting data and receiving data from 4 different components. Here the main hub, if I change the color to, let's say, purple, and I want to change this to, let's say, blue, I click confirm game setup. As you can see, Kevin over here is blue, that's team 1, and Jasper over here is purple, team 2. And as well as that, when I send the data, I'm sending also to the gun. So whenever someone gets shot, or whenever he shoots Kevin, you shoot Jasper. And whenever that happens, you can see that the main hub is sending the data back to the gun that Jasper has died, Jasper has no health. And that's basically how the software communication between every single component in our project is going.
So our vest is equipped with 4 different zones. In each zone, we have an RGB LED and an infrared receiver. Basically, what this does is it allows us to know which zone is being hit at one time. Our stretch goal for this is to be able to have a data sheet that tells us which zone is actually being the one that's hit. But for right now, you could just visually see which zone is being hit. We do experience problems sometimes where there is bouncing from the IR emitter and some of the other zones get hit, but this is just from bouncing. This is not from them being connected. They're all connected to their own GPIO pins on the ESP32. Using this lens, we are able to focus the light from the IR emitter to be able to provide a more precise hit onto the vest. We do still get some of that bouncing, but we are able to be more accurate with our emitter. So this is a demonstration of how far the range actually works for the phaser and the vest.